All right, guys, it's practice test time. We're going to review practice test 15A. Here we go.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, this is practice test 15A. Okay, number one, we're going to solve and classify the system. Okay, so we've got a system of equations, 1/3 x plus 1/2 y equals 8. Our other equation is x minus 2/3 y equals -2. All right, so I think the easiest way to do this is with an F-bomb. So we're gonna drop an F-bomb on this. Remember, the F-bomb is just the least common denominators, or the fraction bomb is least common denominator. So what's the fraction bomb for the top equation? 6. So if we multiply both sides by 6, magical things happen. And what's the fraction bomb for the bottom equation? Just 3. So we're going to multiply both sides by 3. All right, you'll see. So let's do that top equation first. So we're going to distribute that 6 to both of those terms. So we're going to go 6 times 1/3 x plus 6 times 1/2 y equals 48. All right, so now we're going to reduce the 3 and the 6 to 1 and 2. So that's 2 times 1x, or 2x. Then the 2 and 6 reduce to 1 and 3, so that's 3 times 1y, or 3y, equals 48. All right, let's do this one. So this is just 3 times x minus 3 times 2/3 y equals -6. All right, so these 3's cancel, and we're left with 3x minus 2y equals -6. All right, so these are our two equations right here. Okay, so you can solve this by substitution, elimination, or graphing. I'm gonna do elimination just because I can. I'm gonna multiply this top equation by 2, and I'm gonna multiply the bottom equation by 3, and here's what happens. So everything's gonna be multiplied by 2 on the top and 3 on the bottom. So you're gonna end up with a -6y here and a +6y here. So let's do that. So I'm gonna distribute that. So this is 4x plus 6y equals 96. All right, let's do the bottom equation. Distribute that. 9x minus 6y equals -18. All right, now we're gonna add both equations together to get 13x. These cancel, equals 78. All right, divide by 13. And x equals 6. All right, that's nice. So if x equals 6, I'm gonna plug it into one of these equations. Looks like this top one is good. So let's plug it into this top equation right there. So now if x equals 6, I'm gonna have 2 times 6 plus 3y equals 48. Okay, so that's 12 plus 3y equals 48. 3y equals 36. Y equals 12. All right, so final answer 6 and 12. And then we're gonna classify it. So that means, is it dependent, independent, consistent, inconsistent? So what is it? So it's not dependent. Remember, dependent is where it's very clingy, right? So it's not clingy. So it's independent. And it's consistent. Remember, the only thing that's not consistent are parallel lines, and these are not parallel because they intersect. All right, that was number 1. That was kind of a long number 1. Okay, we are gonna skip number 2. This is based on an investigation. If you wanna do it for extra credit, you can, but I am not going to count it towards your normal grade. All right, let's do number 3. So we're just dividing everything by 8x. So 24x cubed divided by 8x minus 16x squared divided by 8x plus 15x divided by 8x plus 7 divided by 8x. Okay? So this is just, it's kind of like the distributive property of division. So we're dividing all that. All right, well, let's just reduce all of this. 24 divided by 8 is 3. X cubed over x is x squared. 16 divided by 8 is 2. X squared over x is just x. X's cancel, and you're left with 15/8. And then you're left with 7 over 8x. So you can write your answer like this. The answer in the book says this. Since these don't really divide by 8x nicely, we just leave it like this. So I'm going to say or. This is 3x squared minus 2x plus 15x plus 7 all over 8x. Either answer works. Choose one. All right, number 4. We're going to simplify this radical expression here. So remember, when you have a square root of a negative number, you're just going to pull that negative sign out and make it an I, okay? So this is negative square root of 81i. Well, what's the square root of 81? Just 9. Okay, so now you're left with negative 5 times 9, which is negative 45i. Good, good? All right, number 5. So we're gonna graph the square root function y equals the square root of x minus 2 and its inverse. Okay, let's do that. So what x's and y's will work? So remember, we want to be left with a nice perfect square under the radical. If we can be left with a 0, 1, 4, 9, 16, that would be awesome. So let's say x is 2. When x is 2, y equals the square root of 2 minus 2, which is 0. So the square root of 0 is 0. So let's say x is 3. When x is 3, then we get the square root of 1, which is 1. When x is 6, we get 6 minus 2, which is 4. Square root of 4 is 2. All right, when x is 11, then y is the square root of 11 minus 2, which is the square root of 9, which is 3. Okay, so let's plot these points. 2, 0 is right here. 3, 1 is right here. 6, 2 is right here. And 11, 3, 9, 10, 11 is about right there. So this is what this function looks like. Okay. All right, let's do the inverse now. So the inverse is x equals the square root of y minus 2. Remember, when you find the inverse equation, inverse function, you are just swapping the x and y and solving for y. So let's solve for y. First of all, let's square both sides to get rid of that radical. That's what we get when we square both sides, right? So we're gonna square both sides. All right, and then we're gonna get y by itself. So y equals x squared plus 2. To get y by itself, you just add 2 to both sides. All right, so let's do a little xy chart for that. So let's say x is 0, y equals 0 plus 2, which is 2. X is 1. That's 1 squared is 1, plus 2 is 3. When x is 2, you get 4 plus 2 is 6. Okay, when x is 3, you get 9 plus 2, which is 11. All right, let's see what that looks like. 0, 2 is right here. 1, 3 is right here. 2, 6 is right here. 3, 11 is about right there. But technically, you guys already knew that, right? Because it just reflects itself over this x equals y axis of symmetry, right? And don't forget the domain and range, guys. For the original equation, y equals square root of x minus 2, remember the domain are the x values. So look at the blue equation. Where does x start? It starts at 2. Anything less than 2 is going to give you a negative number underneath the radical, and that's no bueno. Okay, so your domain is x is greater than or equal to 2. Your range starts at 0 and goes on forever. So your range is y is greater than or equal to 0. Okay? So then you just swap that for the inverse function. So your domain for your inverse function is what your range was for your original function. So look at the green equation. So your domain is x is greater than or equal to 0, and your range is y is greater than or equal to 2. Good, 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 good. Okay, number 6. It says find the area of triangle ABC round to the nearest tenth. So usually when you find the area of a triangle, you need the base and the height. You want in an area is 1/2 base times height, but we don't have that. We're gonna find the area of this triangle trigonometrically. Trigonometrically. That's like 7 syllables. All right, so here's what we're doing. So if you want to look at lesson 71, it gives you the area. Area equals 1/2 BC times the sine of A. All right, we have all that stuff. So 1/2 B, remember, is right across from angle B, so it's 20. And then C is across from angle C, which is 15. And then the sine of A is just 132 degrees. So let's simplify that. That's 300. Half of 300 is 150 times the sine of 132. Well, let's look at the sine of 132, shall we? So 132 sine is that 0.743-ish, 0.743-ish. So area equals 150 times 0.743-ish. Do that math. So times 150 equals 111.47. What's it say to round to? Nearest tenth. So we can just say 111.5, and our label is centimeters, so square centimeters. All right, that's number 6. So you're gonna need this formula to find that area. So you can use this on your test when you take it. Remember, area equals 1/2 BC times the sine of A, or area equals 1/2 AC times the sine of B, or area equals 1/2 AB times the sine of C. So that's all found in the beginning of lesson 71. All right, number 7. So we're gonna find the equation for the inverse of that guy, identify the domain and range, so whatever doesn't break it, of y equals 2x squared minus 3, and its inverse. Okay, so domain and range. So let's look at this first equation, y equals 2x squared minus 3. So we're gonna come down to number 7 right here, and we're gonna rewrite it. So number 7, y equals 2x squared minus 3. Okay, so you can plot these points if you want to, or you can use a graphing calculator, and you can go to that geogebra.com to do that. So let's do that. So we're gonna plug in y equals 2x squared minus 3. And that's what our graph looks like, okay? So our x value, our domain, is basically how chubby it is, how wide it is, and our range is how tall it is, right? So where do our x values start? Well, it looks like it goes on forever, infinity, okay? So it starts over here, and negative infinity that way, and it goes to positive infinity this way, okay? So our domain would be all real numbers. So domain is all real numbers. So negative infinity to positive infinity. All right, well, what about our range? Remember, our range are our y values. So there is a limit. There's a bottom limit, but it looks like the y values go on forever up up high, but they come down to a bottom. There's a bottom to this pit, and it's at -3. So our range looks like this. Our range is y's, which are still real numbers, but y is greater than or equal to -3. I mean, this is just a fancy way to do it. You could just say range is y is greater than or equal to -3. Okay, that's fine. All right, well, let's look at the inverse. Well, let's swap the x's and y's. So x equals 2y squared minus 3. Let's solve for y by adding 3 to both sides first. So x plus 3 equals 2y squared. Now divide by 2 on both sides. So I'm gonna swap sides. Y squared equals x plus 3 over 2. Now we're gonna take the square root of both sides. Now here's the deal. Remember, when you take the square root of both sides, you have to consider positive or negative. So x plus 3 over 2, square root of x, positive or negative, square root of x plus 3 over 2. Okay? So now this is gonna be a little trickier to graph. So if I go to my graph here, this was just me saying y equals square root of x plus 3 over 2. But I also want the negative square root of x plus 3 over 2. So parentheses x plus 3 over 2. Okay, so now I've got this sideways parabola. All right, so what does that mean? That means our domain is our x value. So remember, our domain is all the x's that are greater than or equal to -3. You see that? So -3 is right here. So our x values are all to the right of that. Our y values looks like it goes up forever and down forever eventually. So our range is all real numbers. So you can just do this alien r, and that's fine. Okay? All right, that was number 7. That was involved. Okay, moving on to number 8. We're gonna solve this quadratic equation. Yes. All right, so you have the option to either use the quadratic formula. You can solve by completing the square. You can try solve by factoring, but unfortunately this is not factorable. Okay, so let's solve by completing the square. I'm saying that because this guy is already a square trinomial. Because we know that because 28 divided by 2 squared is 196. So now all we have to do is factor this side. So how does that factor? Well, what two numbers multiply to get 196 and add to get 28? Well, we just figured that out. That was 14. So this is going to be x plus 14 times another x plus 14, or in other words, x plus 14 squared. Okay, now we have to solve for x, so square root both sides. Okay, so x plus 14 equals positive or negative square root of 7. Get rid of the 14. And so x equals negative 14 plus or minus the square root of 7. Done. That's number 8. Let's look at number 9. A gardener has 320 feet of fencing material to enclose a rectangular area of land. She wants the fenced-in area to be 6,400 square feet. The equation W times 160 minus W equals 6,400 gives the width that meets these requirements. Okay, so W stands for width. Use the discriminant to explain why these requirements can be met. Okay, so the discriminant, remember, is b squared minus 4ac. All right, so if the discriminant is a positive number, then it's a real number. But if the discriminant is a negative number, then it's an imaginary root, okay? And then that's not possible. So all we're gonna do is plug in A, B, and C into this. Well, what's A, B, and C? Well, first of all, we have to find the area of this. So let's see, area equals length times width. So how do you figure out what length and width are? It doesn't give us anything. The only thing it gives us is that this whole thing is 320 feet all the way around, okay? So 320 feet all the way around. So you're gonna have length and width, right? How do you find the perimeter? 320 equals length plus width plus length plus width, right? So 320 equals 2 L's and 2 W's. So 2 L's and 2 W's. So let's divide everything by 2 and I get 160 equals L plus W. So the length and the width have to add up to 160. So if your width is just width, then your length has to be, that's where they get this guy here. So if we plug this into here, length times width, that's just 160 minus W parentheses times W, or they already gave you this. So this is our area, okay? So let's simplify this. We'll plug in what we know. So this is area 6,400 equals, distribute that 160W minus W squared. Okay, so now we're gonna write a quadratic. So we're gonna put all of our stuff on one side with 0 on the other. So let's put our stuff on one side where the squared term is positive. So we're gonna move all this over here. So this negative W squared over here becomes a positive W squared. This positive 160W becomes a negative 160W, and that 6,400 is already there, and that equals 0. So now we can determine our A, B, and C. Remember, our A is whatever this coefficient is, our B is whatever this coefficient is, and our C is our constant. Okay? So A equals 1, B equals negative 160, don't forget that negative, and C equals 6,400. So our determinant, B squared minus 4AC, equals negative 160 squared minus 4 times 1 times 6,400. Okay, so remember, if this ends up being positive, then it's gonna work. If not, it's not gonna work. If it's negative, it's not gonna work. Okay, so what's negative 160 squared? Well, that's just positive 25,600. Okay, minus, what's 4 times 6,400? 25,600. Okay, so this is not positive, but it's not negative. It's 0. So that's gonna work. If it was something besides 0, if it was another positive number, then you would have 2 real solutions. But since it's 0, you only have 1. And that's okay, we're okay with that. All right, number 10, we're just changing this to a percent. Oh, that's so nice. So to change a fraction to a decimal, all you do is divide, right? What's 9 divided by 8? Well, that's 1.125. Now, how do you change a decimal to a percent? You just move the decimal over 2 places. 112.5%. Thank you. That was a nice, simple problem. Let's move on to number 11. We are going to evaluate log base 8 of 64. Okay, so we're gonna use our change of base formula. A could be any number. So we're gonna say A is base 10. So log base 10. So in our example, log base 8 of 64 equals log of 64. And remember, when you don't put a base for log, we're assuming that we're talking about log base 10. Log of 64 divided by log of 8. Okay, so we're gonna plug this in on a calculator. Log of 64, so 64 log base 10 equals 1.806 divided by log of 8.903 Okay, we're gonna do that math. 1.806 divided by 0.903. And we get 2. All right, number 12. Okay, so we're given 2 functions. We're gonna find the algebraic difference. Difference is just subtraction. F of x equals 8x minus 9. Domain are real numbers, so anything goes. G of x is x minus 4, and the domain are just integers. Okay, find the algebraic difference, f minus g of x. Okay, so all we're gonna do is we're gonna subtract the function of x minus the function of g, okay? So this equals f of x minus g of x, okay? So that's 8x minus 9 minus x minus 4. Make sure you put those in parentheses because you're gonna have to chicken scratch that. So let's do that. This is plus, negative, positive. So this equals 8x minus 9 plus negative x plus positive 4. Okay, so combine like terms, you get 7x minus 5. Number 13, a student is choosing a 5-digit password. Only the digits 1 through 7 are allowed. So there's 7 possibilities for each placement. How many passwords are possible if digits may not be repeated? So this is nice. They started it for you 7 times and you can't repeat it. So now you only have 6 choices. Then you only have 5 choices, 4 choices, and 3 choices. So what does that equal? Well, that's just 7 times 6 times 5 times 4 times 3 equals 2,520 different possibilities. So that was nice. All right, so let's look at 14. Classify the polynomial by degree and by number of terms, okay? The degree is the most of the time the exponent in each term, but the degree of the polynomial is the degree of the highest degree term in the polynomial. So basically you're just looking for the biggest exponent. So it looks like after I simplify this, let's just simplify this, x cubed plus 7x minus 8x cubed plus 18. Well, you can combine some like terms here. So this is negative 7x cubed plus 7x plus 18. So the degree is 3. So the degree equals 3. All right, and then how many terms do we have? Did we end up with after we simplified? So that's 3 terms. So the number of terms is 3. All right, now we classify it. Since it's a degree of 3, this is a cubic trinomial. So it's cubic because it has a degree of 3, and it's a trinomial because it's 3 terms. All right, number 15, graph the system of linear equations. Awesome, my pleasure. So let's graph this. Remember, when it's x equals something, that's a vertical line. So greater than or equal to negative 6, it's gonna be here. So it's a solid line because it's greater than or equal to. And then our green equation here, well, let's get y by itself because that's better. So x plus 4y is less than or equal to 8. So we're just getting y by itself. So let's throw this x over here. So 4y is less than or equal to negative x plus 8. Now divide both sides by 4. So let's just write that. Divide by 4, divide by 4. And our green equation is y is less than or equal to, well, let's divide that by 4 and it's negative 1/4 x plus 2. All right. So this guy is our y-axis intercept, and the slope is negative 1/4. So down 1/4, down 1/4. Okay, and you can go backwards. All right, so now I'm gonna do something real fancy like. I'm gonna connect these dots. Okay, so there's our green equation. So now we're gonna shade. Well, where are we shading? We're shading to the right of this vertical line, and it looks like we're shading below this line. So it's going to be, what's to the right of this line and below this line? This section right here. Awesome. Fun shadiness. Okay. The other thing you could have done is just shade the appropriate area here, la 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 la, and then shade the appropriate area here, la 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 la, and wherever you shaded twice is your solution set. So this is your solution set right here. This yellow, this lellow. Okay, cool. All right, number 16 is a quickie. We're just determining whether it's a right triangle. So does 9 squared plus 18 squared equal 20 squared? Let's see. 18 times 18 is that plus 81 is 405. Well, not quite. This equals 405. This equals 400. So no, it does not. So not a right triangle. Okay, number 17, let's find the roots of this equation. So basically we're just gonna solve this equation. So x to the 5th plus 10x to the 4th plus 25x cubed equals 0. First step to factoring, take out any common factors. They all have an x cubed in there. So when you take that out of there, you're left with x squared plus 10x plus 25 equals 0. All right, now we're gonna factor that trinomial. So we get, this is a square trinomial, so x plus 5 squared, or x plus 5 times x plus 5 equals 0. So what are our solutions? So this, what will make that 0? Well, 0 will, okay? But it's cubed, so there's 3. You could pick, this has a multiplicity of 3. Okay, well, what x will make this 0? That would be -5, and there's 2 of those, so this has a multiplicity of 2. Okay, that's it. So instead of saying, okay, well, x could be 0, comma 0, comma 0, comma -5, comma -5, we just use a fancy word like multiplicity. It's real fun. All right, number 18, here we go. A researcher visits a park and captures and marks 25 squirrels. Brutal. On a return visit the next week, the researcher captures 38 squirrels, and 18 of them are marked from the previous week. Estimate the squirrel population in the park. What? So we're just gonna set up a proportion. So 18 out of the 38 squirrels are marked, okay? So that means 25 out of the total population should technically be marked, right? All right, well, how do you solve this? That's right, the fish method.
I just don't get it.
So 25 times 38 divided by 18 is approximately, because we're gonna round, 52.78-ish. Okay, but that's kind of weird because you can't have 0.78 squirrels, so we're gonna say 53 squirrels. Because we don't want part of a squirrel. That's really messy. Number 19. Find the measure of one positive and one negative coterminal angle to the angle 72 degrees. All right, so coterminal angles are angles that end up in the same place. So if this is about 72 degrees, well, what other angle ends up at 72 degrees? Well, it goes around one full circle plus 72. So 360 plus 72 is 432 degrees. Okay, and then if it goes around another time, that's like 720. So, or I could just add 360 to this, and I get 792 degrees. So here's a couple possible positive coterminal angles. Or you could go negative. So how do you do negative? Well, you have to go around 360 degrees this way, so negative. So we're gonna go 72 minus 360. Whoa. So that would be negative 288 degrees. Okay? So it asked for just one of each, but I couldn't help myself. Number 20, we're just gonna solve for theta. So here's what theta looks like. Well, here's what the equation looks like. 6 times the cosine of theta minus 3 radical 2 equals 0. All right, so our theta is in between 0 and 360, okay? So let's get theta by itself. Let's add 3 radical 2 to both sides. So we get 6 cosine of theta equals 3 radical 2. Now let's divide by 6. Okay, so we get cosine of theta equals radical 2 over 2 because this reduces to 1/2. Okay, well this should look familiar, right? This is radical 2 over 2. Where is cosine of theta radical 2 over 2? So look at your unit circle. So cosine is 1 here. At here, it's radical 2 over 2, and that's 45 degrees. So one of our answers is radical 2 over 2. That's 45 degrees, but where else is it? Positive radical 2 over 2. So if you come all the way over to here, this is also radical 2 over 2. That's where cosine of theta is radical 2 over 2. All right, that's it for practice test 15A. 15B is not going to look any different, really. So if you understood this, you'll be fine with test 15B. So let me know if you have any questions. Have fun.
Flack math! Give me some math and I'll give you some flack. Flack math!